way, because it could just be a big square, right? Why is it set up in this weird way? Well, that's because different columns have different characteristics. So there has to be certain atoms in certain columns. That's the up and down, right? And certain atoms have to be in the rows, the periods. So the up and down are groups and the rows are periods. So this is terminology you've got to know. You have to know a period and you have to know a group, which is the up and down. Now, back in the Stone Ages, when I was in school, they used to call the groups, the up and down, the columns, they used to call them families. And I like that better than we call them groups now, because family means you got something in common with it, right? Your family, you might look like your family or you might act like your family. Okay, and that's what the elements do in the groups. They act like one another. They have characteristics that are the same. And that's why they're all grouped together, right? All right, so you have to know 4 groups, and they're the important groups. And the first group is the alkaline metals. That's what this group is right here. Oh, okay. I clicked on something. I didn't know what was going to happen, and I wasn't what I was hoping that would happen. All right, so these are the alkali metals. Okay, they act a certain way because of their electron arrangement. Okay, let's look at this. Nope. All right, that is not what I had hoped would also happen. All right, let's go back to this. The alkali metals are an earth metal. They're metals. All metals are from here over. And you see this blue line. So some of these are still metals. So aluminum here at 13, gallium, 10 is also a metal. So from here left are all metals, all right? Metals have a certain property. They're solid at room temperature. You can hit on them and they're malleable. That's what that malleable means. You can hit on them and they just kind of form a shape instead of breaking. Okay, so all metals have a certain property. And so all of these have a certain property. Now, some of the groups have different properties. So the alkali metals here are more reactive than all the other metals. So when we say more reactive, that means that they will combine with other things really, really easy. Okay, so like they're the partiers. They want to get with other people, be with other people, and they don't really exist in nature by themselves. They're always combining with something else because they're very, very reactive. So if I put any one of those, except for hydrogen, in water, it's going to spin and it's probably going to set itself on fire, if not blow up, because it's so reactive. And you can find lots of YouTube videos out there that shows that. It's pretty cool. Just like alkali metals reactions. All right, these next column, next family, next group, are the alkaline metals. So just a little I and E there in the end. And they're also very reactive, but not as reactive as the alkali metals. So these 2 groups are very reactive because of their electron configuration, how their electrons are. In the alkali metals, you never find them in nature by themselves. So when we say find them in nature, because that's a terminology that's on your test, find them in nature by themselves, that means not combined with anything. Okay, it's just a pocket of lithium. You don't find that because they're so reactive because they only have one electron, one valence electron. And because they only have one electron, it's very easy to give it away and combine with something else. Well, that's the same with alkaline metals. They have 2 valence electrons, and so it's easy to get rid of them and combine with other things. Now, these metals right here are transition metals. They're just the metals in between. Okay, and then those metals right there are also metals. So from here over, here to the left, are all metals. And the rows down here on the bottom, those are all metals. Okay, all metals. And so the periodic table is mostly metals. Now, metalloids. Do I have here, metalloids. There we go. These are the metalloids. There are very, very few of them on the periodic table. And so a lot of periodic tables will have this black mark as a stair step. And that stair step touches all of these metalloids. So if you see a periodic table with a black mark there that looks like stairs, that's because it's denoting, it's designating, it's showing you which one are metalloids. And the deal about metalloids are that they have properties of metals and nonmetals. Okay, so they're the barrier between metals and nonmetals. And so they kind of go both ways. They could have some properties of metals and some properties of nonmetals. And then the nonmetals are over here. Those are all the nonmetals. So you see that metals take up most of the periodic table. That's what most elements are, metals. Now, these nonmetals here are in 2 groups. The first group you have to know, let's see, well, we're going to look at the noble gases. The noble gases, so some of the properties of nonmetals are that they could be gases at room temperature, some of them are liquid at room temperature, and some of them are solid at room temperature. So generally metals are all solid at room temperature, but nonmetals are different. They could be one of those. Oh, they also will, if they are metal, they'll be brittle, and metalloids are definitely brittle. Just some characteristics, and that's asked in your test too. So the noble gases here, and you see these all the time. If you see a neon light, it's one of the noble gases, right? A big open sign in a store or something, that'll be a noble gas. It'll just be a noble gas in a little glass tube, and they'll fill it with it, and then they'll put some electricity to it, and then it lights up. So that's the noble gases. They are very unreactive. Yes, you would find them in nature by themselves because their electron structure, they have a full energy level. They can't take any more electrons. Now that's what the nonmetals do. They take electrons. They want to take electrons because they want to have a full energy level, just like the noble gases. The noble gases are like the kings and queens. They're the nobility. They are better than everybody else. And they're perfect. They're what we consider perfect on the periodic table. They have a full energy level, and so they will exist by themselves in nature because they will not have any more room to take any more electrons. That's really important, for this test and going forward. So these nonmetals here, they take electrons because they're trying to get to a full energy levels like the noble gases. So that covers a lot of the information of the periodic table. Trying to think what else was asked on your test about periodic table. Reactivity. That's all I can think of. Y'all got any questions about a periodic table? Now, we did not go over trends. Trends is what I went over earlier this week. So this is just periodic table information.